For our first calculation problem, we have how much energy must be absorbed by a 150 gram sample of ice at 0 degrees Celsius that melts and warms to 25 degrees Celsius. Okay, so first of all, we have our graph over here, and it starts out at 0 degrees Celsius. So this first part right here is the phase change from a solid to a liquid, and then it starts to warm up to 25 degrees Celsius, which would then change from a solid to a liquid at this point. So this is now a liquid. So then we come over here to find the phase change. So our equation is Q equals mHF. The Q stands for the energy change, and then the M is the mass, and then that's going to be times by HF, which is the heat of fusion. So for this, we would do melting. So first, we would plug in the mass for 150 grams, and then times that, our heat of fusion, which would be 334 joules per gram. Then we'll multiply that together to get 50,100 joules. And then because of stick figs, we would have to change that to 50,000 joules. And then to find our temperature change, we would use the equation Q equals N times C times the temperature change. So for mass, which is M, we would plug in 150 grams. And then for C, that is our heat capacity of liquid water. So we would plug in 4.18 joules per gram degrees Celsius. And then for our temperature change, we would have to do another equation. So we would have our temperature change equals our final temperature minus our initial. So our final temperature was 25 degrees minus our initial, which is 0. So our temperature change would then be 25 degrees Celsius. So then we would multiply that all together. So everything times 25 degrees Celsius, which then equals 15,700 joules. And then because of stick figs, we would have to then round this to 16,000. Joules. And then we would have to add up our 50,000 with our 16,000. Which would then give us 66,000 joules. And this is our first problem. For our second calculation problem, we have a 12-ounce can of soft drink, assume mass equals 340 grams, at 25 degrees Celsius, is placed in a freezer where the temperature is negative 12 degrees Celsius. How much energy must be removed from the soft drink for it to reach this temperature? Okay, so first, over here we have our graph, and our graph starts at 25 degrees Celsius, which is our starting temperature, and it is liquid at this point. And then right here, we have a phase change from a liquid to a solid. And then at this point right here, which is at the end of our graph, it's at negative 12 degrees Celsius, which is our ending point, and is now a solid. So that's just a visual to help us solve our problem now. So our first equation we solve is Q equals mass times the heat capacity times our temperature change. So to find energy, our mass is 340 grams, and we're going to times this by our heat capacity of 4.18 joules per gram degrees Celsius. And then for our temperature change, this is going to be negative 25 degrees Celsius because our temperature is decreasing. After multiplying this all up, we get negative 36,000 joules. And then for our next equation, to find the phase changes, our M, so our mass is 340 grams times negative 334 joules per gram for our heat of fusion. And then after multiplying this all up, we get negative 11,000 joules. Once again, this is because we have a decrease in temperature. And then for our last equation, to find the other part of our temperature change, our mass is, once again, 340 grams times our heat capacity of 2.1 joules per gram times our temperature, which is 12 degrees Celsius. And after multiplying this all up, we get negative 8,600 joules. And then for our heat capacity, it's 2.1 because it's a new phase. We're now in the solid and not in the liquid. So then after adding all of this up, we get negative 154,600 joules. And then with stick fix, it would then become negative 1,500,000 joules lost. And this is our second problem.